So I also like to give you a brief update on an area which is or getting more and more important for us, which is high-speed CT. And one of the key applications or needs today to achieve faster CT results is battery inspection. We all know that the trend to use more e-car mobility is a mandatory target, and especially in respect of safety, the batteries are really a critical component. What is really inspected, or what is mainly inspected, is what we see here, the offset between the anodes and the cathodes. So if you stack together in a car battery, we have up to 250 layers. If you stack together this battery, it's really tough to test this and control it. So this is why a lot of this manufacturers are using now X-ray to make sure that the offset between anode and cathode is correct and can avoid the short in the field. Yes, this application is requiring really super high speed, and we see a typical setup for, in this case, it's a smartphone battery. So it has a rotating table, and the example which we see here is a real setup. It's using a Tor FX10 512, but with 10 gig interface, and also FX20 200mm by 512 is also now available, which can be used for the automotive batteries. So, and some real results on this next page, but in this case the original setup was with acquisition time of 110 milliseconds per projection, and this was, first of all, we doubled the speed to 55 milliseconds, and in the next step to 27 milliseconds using our Tor setup. And you see this on the slice quality of this example. This was still perfect. So the motion system was then not capable to do more. So we can consider that at least factor 3-4 times, but most likely it goes up to 5-6 times faster setup by using this photon counting for this kind of application. So that's a significant improvement of speed, and for this battery production, 5 times faster CT has definitely some value.